Okay, this is the second part of the notes for work rate, section 7.8. A mailroom manager can do a job in 3 hours. When she works with an assistant, they can do the job together in 2 hours. So the question is, how long would it take the assistant to do the job by herself? So we know the manager's work rate. Her work rate is 1/3. The assistant's work rate is what we don't know. So her work rate would be 1/x. We do know that if they work together for 2 hours, then the assistant and the manager can get the job done, completed in 2 hours. So completing the chart and staying with the same process, the manager's rate for 2 hours, the assistant's unknown rate for 2 hours, working together gives one complete job. Using the LCD method, and then when I subtract 2x, 6 equals x, which means that the assistant could do the job alone in 6 hours. Okay, here's a pipe problem. An inlet pipe can fill an empty pool in 4 hours. So that means the fill pipe's work rate is 1/4. A drain pipe can empty the pool in 8 hours. So the drain pipe's work rate is 1/8. How long will it take to fill an empty pool if both pipes are accidentally left open? The fill pipe is considered positive, and the drain pipe would be considered negative. They do opposite jobs. So how long will it take to fill the empty pool if both pipes are accidentally left open? Time is your variable. And when you set up the equation to solve for this, let the drain pipe be a negative number. They're doing opposite jobs or serving opposite purposes in an effort to do the same, or an effort to fill the pool. So using the LCD method, LCD is 8. So you conclude that what would normally take the fill pipe 4 hours to do will now take the fill pipe 8 hours. 8 hours to fill the empty swimming pool if the drain pipe is accidentally left open. Okay, here's a machine problem. This is number 13 on page 329. Machine A works twice as fast as machine B. When they work together, they can do the entire job in 3 hours. How many hours would it take each machine to do the job alone? If I let the slow machine be represented by x, then the fast machine could be x/2. So the work rate for the fast machine would be 1/x/2, or your complex fraction, simplified. That would be 2/x. And then the rate of the slow machine would simply be 1/x. If they work together for 3 hours, how long would it take each machine to do the job alone under these conditions? So this is our problem. Here the LCD is x. So I end up here. And to interpret this, machine B, or the slow machine, would need 9 hours to do the job, which means the fast machine would be 9/2, or 4.5 hours. You can also work this problem letting machine A, the fast machine, be the x, and then the rate for machine B would be 2x, and you end up with the same answer. and the X result would be 4.5, which you would then double to get the other answer.